All right, so 2.5, number 35. How do we do it? Suppose you take the point 4, negative 2. It's a point on the graph. Okay. What point is on the graph of that? So we got the answer there already, but how do they get that? Okay, let's take a look at it. So we're going to go y equals g of x plus 3 minus 1. And the question being asked of us is, where is the point 4, right over here, 4, negative 2, and it's a point, right? So this is x, this is y. It's not an interval. It's not x, right? It's a point, x, y. So where's that point going to go? You know, this is on normal g of x. See what it says up here? G of x. 4, 2 is on g of x. So what's going to, let me move this down. So where is that point 4, negative 2, which is on g of x? It's where, it's going to go to where on g of, what are they asking here? X plus 3 minus 1. Where is this guy going to go when you start doing this weird stuff with the function? That's the question, right? So where's it going to go? Okay. Let's take a look. So what's that? What is that plus 3 in the parentheses going to do?
Left 3. Horizontal.
Yeah, left 3. Remember, x is always opposite, and that's certainly an x effector. He's in there with x, and x always opposite. That's going to be left 3. And what's that minus 1 going to do? Down 1, right? Down 1. So that one's pretty easy. Left 3, down 1. So you just take the 4 and you go left 3, oh, down 1, negative 1, huh? Negative 1, right? Just take the x value, subtract 3, take the y value, subtract 1. So that's pretty easy. That's going to be minus, not minus 7. That's 4 minus 3. That's 1 minus 3, which is exactly what they got. Good so far? Now's where it gets tricky. So part B, now they're going to do more fancy stuff. So we're going to start over again. So let me go to a fresh screen on that. And now in part B, they're going to say y equals minus 2. Well, again, here, wait. I should start with the original again. So start with 4, negative 2. 4, negative 2, which is on the normal g of x. And the question is, where is it going to go on g, or minus 2, minus 2 g of x minus 8 plus 9? Where does it go to? To where does it go? Okay, so good so far. So I'm doing part B now. Part B. We have the answer there. How'd they get it? So you take 4, negative 2 on the original. Where's it going to go when you do all that stuff? Well, okay, what's the minus 8 going to do?
Positive.
Yeah, right 8, because x is opposite, huh? And what's the plus 9 going to do out there? Up 9, because y is normal, right? That's a y, because it's out of the x zone, right? What's that negative 2 going to do?
Flip it on the x-axis. Stretches or compresses it?
It's going to flip it vertically. It's a y effector, and stretch it 2 times as tall and deep, right? Because that's a y effector. What would an x effector would be like that guy? We'll get to him in part C. That's an x multiplier. That's doing a sideways kind of thing. Part C. But here on part B, this negative 2 is a y guy. He's a y effector, right? He's not in x's world. So he's going to do a vertical thing. So the negative is going to flip it vertically, and it's going to stretch it 2 times as tall and deep. Okay, well, what's my problem? What was the problem all the time on Monday? I kept saying, it's all good, all these rules are great, except when a certain thing happens, you got to watch out and be really super careful. Yeah, 2
of the same two
in this.
when there's a stretch and a stretch or shrink or a translation both in the same direction.
Yeah, well said, Joshua. Exactly. When you both move and flip in the same direction, because then the order matters all of a sudden. You're with me? Just think about a graph for a minute. If I say, hey, take that dot, move it up 3, and then flip it, well, then it'll end up way down 3, won't it? But if instead I say, okay, take that same dot, same starting spot, and I go flip it first, then move up 3, it'll end up there. See how the order matters? Whether you move first, then flip, when they're in the same direction, because they're both going vertical there. So if you both move and flip vertically, or move and flip sideways, the order matters, whether you move first, then flip, or flip first, then move. It's going to result in something very, very different. So that's the issue with this one. Do you see it? What do we have? Both vertical or both horizontal? We have both a movement and a flip. What? Vertically or horizontally on this one? What do we have both of?
Vertical.
Both vertical. This is a vertical flip and a vertical. We don't care about the -8. No mystery there. Right 8. That's easy. Just add 8. Going to be 12. Sure enough. The x value's obvious. Going to be 12. One thing's happening to x. Add 8. Right? Because it's opposite. So that's easy. That's not the problem. The problem is y. What's happening with y? Think, well, add 9 and then -2. Yeah, but which one's first? Do we do the -2 first and then add the 8? Or the 9? Or do we add the 9 first, right? Because this is adding 9 to the y value. So I could take that -2y value and I could add 9, maybe, get 7. And then go times, because that's multiplying the y value, isn't it? Times -2 and get -14, but that ain't what they got. They must have done it in the other order. They must have first went times -2. If you take that times -2, you'd get +4, right? And then added the 9. Sure enough, they did, 13. Now, how'd they know that you do it in that order? Is there like some kind of rule that you always do the multiply first? No. That'd be nice. If it was that simple, I wouldn't be making a big deal. I'd just go, yeah, just always multiply first. All good. Well, I'd also ask why. Why multiply first? Turns out, when for vertical, you multiply first. For horizontal, you do the adding, subtracting first. That's the rule, if you want a rule. But I don't know if you like that. I hate math like that. I think, why? Who cares? Because somebody sat around and made up a dumb rule? I want logic, reasons, truth. So I'm going to show you that, but time is so limited. Yeah?
Could you say the order again, like vertical and horizontal?
Do you really want those? Like, who cares? So to me, I would say, who cares?
I need that on the note card, though.
We're here to learn truth, though, right? I mean, isn't your desire truth? Like, if somebody said, such and such is true, I'd be like, why? Why? I want to know why is what's interesting to me. Like, why is that true? Like, how does that work? I will. I'll summarize. Well, here, I can write it up. I know. People always want. One time, I remember this summer, I was teaching pre-calc, and I showed a certain trick on a certain problem. I just thought, well, I'll just show them this trick. They were into that thing. They remembered it, and on the exam, they wanted me to tell them again, and I'm like, really, guys? I mean, who cares about dumb tricks? But anyway, so for me, it's truth and logic, but people like dumb tricks sometimes. Yeah,
I did the help me solve this in the upper right-hand corner,
right,
and it made it super easy.
Did it?
Yeah.
Okay.
Yeah. If you go through those steps, it breaks it down into 4 steps, moving from left to right, and it makes it super easy.
Okay. So what would you tell me to do here?
First, start with the negative, which flips it on the x-axis, right? And
So
then
the -2?
Yeah.
So I multiply.
It flips it on the x-axis, which means it flips it upside down. The
Right.
2 compresses it, right?
Right. Well, no. That's all right. That's right. I'll lead it through. So I would ask you, though, from the Math Excel, why do you start with the -2? Why don't you start with the +9?
Because it's vertical.
Why does vertical mean you start with the multiply?
I don't know. It was way easier when they showed it to me on the
All right. So, so the deal is, when you have vertical, both a flip, or both a multiply and an add subtract, you do the multiply first. Well, first do the multiply, and it's the other way. It's the other way for horizontal. For horizontal, if you have both multiply and add subtract, if you have both going sideways, which is part C, we'll see that. You first do the add subtract. Now, like I said, to me that is completely boring. Like if people said math is, I would go, if that's how people are doing math, I would say, yeah, how boring. I mean, just blah blah blah. The law, to me that's like law, which is to me kind of boring. Like the state of Connecticut has passed a rule that no skateboarding in the park. I mean, just oh my goodness, I can go to sleep with that. Like, who cares? So if that's how math is to you, then I would be with you and say math is so boring. Just rule after rule after rule after rule. Who cares? No, There's a beautiful reason why that's true. There's logic behind why that's true. Let's see it. But then I'm using up all of our time, aren't I? All right, so why? That's what's interesting to me. And learning to think those thoughts better and better and better so you can derive truth for yourself. That's really the goal of math and science, is to make you a good logical thinker. Now, why? How do we know? Why is that true? Well, take the equation, okay? And let's try it both ways. And you'll see that one of them results in this and the other one does not. That's why it's true. What do I mean? What if I try to, now I'm saying for vertical, you're supposed to first do the multiply. So what if I tried to first do the adding, subtracting stuff? Why would that not work? Let's see it not work. Oh, by the way, the x stuff doesn't matter. I'll just stick the x plus 8 in there. We're not, or what is it, minus 8? We're not talking, the x is, good. We're not messing with x, right? There's only one x thing, no problem, great. But let me do the y stuff now. There's two y things I'm going to do. I'm going to multiply by the front. Well, that's not right. There's going to end up being a minus 2 in the front, and I'm going to add a number in the back. Those are both y effectors, aren't they? Let's try to first do the add subtract. And we'll see it's not right. Now, here's what you got to keep in mind, though. To faithfully do these operations according to what is true, according to truth, you're not just plopping numbers here and there. That's what it might look like in the end, but that's not what's true. What's true is you're replacing x with something, which is slightly different than just plopping a number. You're replacing x with whatever, or replacing y with whatever. So let's do it. So I'm going to do the first step. I'm going to do the adding, subtracting step first. So I'm going to take y, and I'm going to what? Add 9. Add 9. Okay. G of x minus 8, add 9. Looks good. We're almost there. Okay, second step. What am I going to do second step? Multiply y by negative 2, right? Because we're going to get that negative 2 in the front. So, do you see the problem now? If I multiply y by negative 2, what is y? All of this. I can't just put it in the front. That's not multiplying y. That's multiplying part of y. I got to also multiply this guy, and he's no longer a 9. Do you see that? If I multiply all of y by negative 2, that means all of y. That becomes negative 18, which is not what this was. So do you see, if you think add, subtract first, then multiply, it just does not result in the equation they gave me, which says, they did not. To get that, they did not add, subtract first, did they? Or they wouldn't have got that. So now let's try it the other order and see it actually work in the other order. So if you do the other order and you say, okay, first multiply y, okay? So again, I'm starting with y. I'll just stick the x part in there, right? We start with the x part already. We don't care about that. So first multiply by y by negative 2, okay? All there is this right now. That's all I have right now. So if I multiply all of y, then that's all there is to do. And then add your, whatever it is, 9, to all of y. Well, okay, I'll add that to all of y. That just adds 9. Perfect. That's what they ended up with. That's the order they followed. Do you see how I discovered that? Without somebody needing to plop down a rule? Who can remember all the rules? Follow logic. That's always the best way. But that takes training and practice to get better and better and better at thinking that way, clearly, carefully, precisely. So that's what they did. That's how I know. I literally don't know the rule until I think it out. I don't walk around with these things in my head. Why? Does that make sense? Whereas the x now, so that's what they did. So that tells me, oh, they first multiplied, then they added, because that's the only one that ends up in the real equation they showed me. The other one ends up with a minus 18. So they must have first multiplied. So that means I go back and I go, oh, okay. So I'm going to get rid of all this mess, and I'm going to first multiply the y value, if I can get rid of all this mess here. So I'm going to say, okie dokie. So let's come on back and take, what was the point? It was 4, negative 2. So 4, negative 2. I'm going to first multiply the y value by negative 2. So that'll become positive 4. And then I'm going to add the 9, which makes it 13. The other one was just adding 8, huh? So 12, 13, that's what they got. See that? Yeah, that's true. Whereas with x, let's do part C really quick. So I knew this problem would take a long time. Part C, then, to be faithful with part C, you see they have two things going on for x, right? So again, we're starting with 4, -2. I'm doing part C now. 4, -2. And now we're going to do y equals g of, 2x plus 8. So those are two actions, both on x. Both a multiply on x and an add on x, huh? So, what order should we do it in? Turns out the other way. Well, how do you know that? I'm just going to work it out and show you. If you thought it was right to multiply first, that would be wrong. Let's try it. First, multiply. Okay? And then we'll do the add. Now, here's part of the trick. It's actual replacement. That's what you have to know. It's replacement is what it is that's what actually makes these actions happen, is replacement. Now you might think, what do you mean replacement? Well, you'll see the problem as we go. So if we just start with g of x, and I say replace x with, multiply first, right? So 2x. So I take the function g of x, and it becomes g of 2x. Okay, great. No problem. Looks good. Second, do the, adding of the 8. This is the wrong order, and we're going to see why. Second, add the 8. Now here's where you don't want to make the mistake of just going, well, there it is, just add the 8. It's good. You didn't do replacement. Remember what you're supposed to do? You're supposed to replace x with x plus 8. Replace x with x plus 8, because that's what it actually is. And I probably didn't make that super clear just because I didn't have a lot of time. That's what it really technically is. And you won't, I'm not going to push you hard on this. There's one question on the actual exam and on the practice exam, I think you saw it, number 25, that pushes you a little bit about something like this. Just one question. So replace x with x plus 8. So if I take, so I can't just plop an 8 on the back, you see. I can't just plop an 8 back there. Instead, I take x. It's like plugging into a function. I take x and plug in x plus 8. So that would become g of 2 x plus 8. Can you see that? And you see, you multiply that out, that's a 16 now, which is not what they have here, proving that's not the order.
You put add 8 on there, wouldn't it be subtract 8?
Isn't it opposite when you take it out?
Right. And we can get into all that kind of stuff. That's the effect on the graph. You're right. I'm doing the equation right now. That will be the effect on the graph.
Oh, okay.
Yeah, they added 8 to the equation. Well, they added 8 first to the equation. Oh. Yeah, all that stuff will move over to opposite effects on the graph when I get there. That's true. And on the point, you're right. But I'm just talking about equation-wise, that doesn't even work. That's not what they did to the equation. Or they would not have gotten 2x plus 8. They would have got 2x plus 16. Do you see that? So that you got to know it's replacement. I know that's a subtle truth. Why is it replacement? Because that's what works. I don't got time. Come on, officers. Be glad to show you more about that. But that's what you're really doing with these graph maneuvers. It's replacing x or replacing y. Y I didn't have to show so much detail because y equals that whole side. So we really were replacing. But so you see the deal? You're replacing x with x plus 8. So if you just try to multiply the 2 first, and then replace that x with x plus 8, then that's going to become 16. That order doesn't work. So they did not multiply first, or they would not have gotten this. So you tell me they added first? Yeah. Let me go back now. One more. It's like the fifth screen on this thing. So the real order, what they really did on part C, is they, what'd they do? They added first. So add 8 first. They first added 8, which again means replace. So if I take g of x and I replace x with x plus 8, good so far. And then I second replace x with 2x, the multiply step, right? So if you take this x right here and you plug in 2x, it's perfect. That's what they did. So that's just what works. So for x stuff, you got to do the adding first. For y stuff, you got to do the multiplying first. But if that's just some rule to you, how boring. How hard to remember. Can you remember all that stuff? You got a way better memory than me. Well, 3x5 card? I guess you can do 3x5 card with some of the stuff anyway. What's that? Yeah, so yeah, okay, I was just showing the equation. Yeah, so let's do the actual graph. So that means that equation-wise, we have to add first to the equation. So take the point, you're right, I should finish this up after all that, huh? Take the 4, -2, and add 8 to the x value. So that means actually subtract 8, huh? Because it's always opposite on x, right on. So that'd be -4, -2. Good so far. That's that step, it's opposite. And then 2 times x, opposite. Take that x value and divide by 2. -2, -2. There it is. So yeah, when you go to the actual graph point, opposite, opposite. I was just establishing the order in the equation, which was very important. Benjamin.
I was thinking a way to remember why the order is different is because for the horizontal, the x stuff, it always does the opposite, so it does the opposite for the order of operations.
Yeah, that'll work. That's a nice memory device.
And y stuff does the same.
Right, because the order of operations is multiplying is before adding, subtracting.
Yeah.
So that's normal. And x is doing the opposite.
That's where I get the compression and the stretching.
Right.
If it was x, it would have been stretching. Or no.
So that's a nice memory device, and that's helpful. But I would encourage you, especially if you want to go the way of math science, you want to be a physicist or a biologist, or what's most helpful to you would go back over this later. My teachers would do this kind of thing, and I'd be very confused, and then I would spend hours of my life in the library and my desk at home, and I would try to think back those thoughts. The more you do that, the sharper your mind will get at precise, logical thinking. That's really what needs to be developed in you if you want to go the way of math science. Not dumb rules. You'll never use that rule in your life, probably. But if you learn to think that way, that will you'll use, that kind of precise, logical thinking. That's what's most valuable.